All right, for number 10, this is chapter 6, extra practice problem number 10 in stoichiometry. And it says a compound has an empirical formula of CH2O. If its molecular mass is 60.0 atomic mass units, what is its molecular formula? So essentially what we're going to do is we are going to find the molecular mass of this and then see how it relates to the molecular mass that we're given. If they are equal, great, then our empirical formula is our molecular formula. If not, we're going to see what multiple of it that it comes out to be. So let's step through it together. Some of you may have this concept, in which case, why are you watching this? I mean, thanks for coming. But let's assume that we need a little help with this. All right, so what we're going to do is we're going to get our atomic mass of this little guy just like we do all the others. I'm going to put all of the symbols that I have here, and then I'm going to put the number of atoms in this empirical formula here. And I'm going to take the atomic mass from my periodic table of elements, and I'm going to put that in here. Okay, 16. All right, and then I am going to multiply those. Not hard math for me this time. Thank you. All right, 2.016 and then 16. All right, and if we add this up, we are going to get 0.03. Startlingly close to 30.0, isn't it? And actually, we're going to, for sig figs, we would be at 30.03. All right. Now we look at this and say, all right, I've got 30.03 atomic mass units, and this is 60. If I were to divide, I'm pretty sure all of you guys can do this in your heads, but if I divide 60 by 30.03, I am going to get 2. All right? And that means that this molecular weight is twice as heavy as this particular empirical formula. What that tells me is that I need to double the amount of atoms I have here in order to get the correct molecular formula. So I have 1 here, so I will make that 2. I have 2 here, so I will double it and make it 4. And I have 1 here, so I will double that and make it 2. So if you wanted to double check yourself, if you didn't want to take my word for it, or you didn't believe what was going on here, go ahead and do this operation with this formula, and it will get you to 60.00, maybe a little bit extra, but close enough that you can say, yep, this is what we got. The difference, in the little extra bits here is that the periodic table I'm using is a little more precise than the one that's in your book. But when we're talking about this, we're looking for a hard integer ratio. They're going to give you math that works well. Works super, super close that you're going to be able to get this. They're not going to give you something like 0.76 and then you've got to try and figure it out. They're not going to do that to you. So that's it. Hope all is well. Take care.